Okay, on this example, we're given that secant of t is equal to negative 17/8. We're given that our angle t is between 0 and pi. So our goal is to find all of the trigonometric ratios. So to do this one, what I'm going to suggest is just going to draw a triangle, and then we're going to focus on which quadrant we end up in to help us out with positive or negative as far as our signs go. So as I'm drawing this triangle, it's going to be a right triangle. And I want to label exactly which corner, which angle is going to be t, because that's the angle being plugged in here. Now, we are given secant of t is negative 17/8. That also gives us that secant and cosine go hand in hand because they're reciprocals of one another. That what we can do is we can invert numerator and denominator here, and we'll get cosine of t. I always like to focus on sine, cosine, and tangent, as opposed to the other three. I typically get cosecant, secant, and cotangent if they're not given to me based on these initial three. All right, so from here, SohCahToa tells us that cosine is going to be adjacent over hypotenuse. So to label my sides, and I'm kind of ignoring that negative for the time being, my adjacent is going to be 8, and the hypotenuse is going to go as 17. To get sine, the next one I'm going to focus on getting sine here. Sine is going to require opposite over hypotenuse based on SohCahToa, so we don't know the opposite side length. So let's do a little bit of work and find that opposite side length. I'm going to call it a for right now. So we can say a squared plus b squared, 8 squared in our case, is going to equal 17 squared. So the Pythagorean Theorem, a squared plus b squared equals c squared, is going to help us out in this case. Okay, so a squared plus 64 equals kind of big number, but 17 squared, 289. All right, from here, what we can do is we want to isolate the a squared, so we're going to subtract the 64 from both sides. So 289 minus 64 is going to leave us with 225 on the right-hand side. And then to get a all by itself, we'll apply a square root to both sides. So we end up with a equals 15 with a little reducing down here. Now, I did kind of ignore my positive or negative. We did apply a square root, so this could be both either positive or negative. I tend to ignore that as I'm just setting up a triangle, visualizing a nice triangle, not drawn to proportion or anything like that. We will account for the positive or negative in just a second based on which quadrant we're in. All right, so sine of t, that has to be opposite over hypotenuse based on SohCahToa. So in our case, we can say that's 15/17, opposite side, hypotenuse. All right, from here, we also want to be a little bit careful about which quadrant are we actually in. So as I'm thinking about which quadrant we're in, I usually just use this phrase, all students take calculus. All students take calculus. What that tells us is all of our angles or all of our trigonometric ratios are positive in the first quadrant. Only sine is positive in the second, tangent in the third, and cosine in the fourth. All right, so we already were given that cosine turned out being negative based on this reciprocal identity. So if our angle is between 0 and pi, what that means is the first or second quadrant. But because it's negative, that means we have to be in the second quadrant. So being that we're in the second quadrant, sine is going to be positive. And I'll put a plus out in front here. You definitely don't need to include a positive when it's going to be positive 15/17. All right, so now that we have sine, that also gives us cosecant. Remember that these are reciprocals of one another, so you can say, well, we just have to flip it upside down and say 15/17, also going to be positive. We just inverted our fraction. All right, the next one I'm going to get is tangent. I know that tangent is given by sine over cosine based on a quotient identity. So if I have sine over cosine, what I'm going to do is I'm going to fill in my sine, 15/17, divided by our cosine, which is negative 8/17. Now let's do a little bit of reducing down. So we have fractions inside of fractions. This would be a little bit better answer if we got rid of fractions inside of fractions. I think the easiest way to do this is going to be multiply by 17/17, both numerator and denominator. That way, multiplying by 17 will counteract this dividing by 17, therefore giving us 15 up in the big numerator. And then very similarly, multiplying and dividing by 17 creates a 1, so these will basically eliminate each other. We'll be left with -8 in our denominator. So we can say 15 over -8, or you could move that negative out in front. Finally, we want to get the cotangent of t. These are reciprocals, tangent and cotangent, so we can simply invert numerator and denominator, get -8 over 15, we'll have cotangent. All right, hope this helps out as we're finding all of our trigonometric ratios using a triangle in this case. Do be very careful about positive or negative. I like that phrase. All students take calculus to help us out on that. Good luck.